Hello students, welcome to the lecture on operators and expressions. And after the lecture we will be able to learn the following objectives. Explain operators and expressions. Understand arithmetic and unary operator. Define the logical and bitwise operator. Define preprocessor commands. Explain hash include and hash define preprocessor. Understand about input, output, and its functions. Let's start with a brief introduction to operators and expressions. In order to perform different kinds of operations, C uses different operators. An operator indicates an operation to be performed on data that yields a new value. Using various operators in C, one can link the variable in constants. An operand is a data item on which operators perform operations. C is rich in use of different operators. For example, the expression shown here can be interpreted as a multiplied by b plus c or a multiplied b plus c. But the first interpretation is the one that is used because the multiplication operator has higher precedence than addition. Let's discuss the concept of operators and expressions. C programming language provides several operators to perform different kinds of operations. There are operators for assignment, arithmetic functions, logical functions, and many more. These operators generally work on many types of variables or constants, though some are restricted to work on certain types. Most operators are binary, meaning they take two operands. The first expression, which employs the addition operator, plus, represents the sum of the values assigned to variables a and b. The second expression involves the assignment operator, equals, and causes the value represented by y to be assigned to x. In the third expression, the value of the expression u plus v is assigned to t. The fourth expression takes the value 1, true, if the value of x is less than or equal to the value of y. Otherwise, the expression takes the value 0, false. Here, less than equals is a relational operator that compares the values of x and y. The final example causes the value of j to be increased by 1. Let's now talk about arithmetic and unary operator. There are some main arithmetic operators in C. They are plus for additions, minus for subtraction, multiply for multiplication, divide for division, and percent for remainder of integer division. This percent operator is also known as modulus operator. For exponentiation, there is no specific operator in C. Instead, there is one library function known as power to carry out exponentiation. If one or both operands represent negative values, then the addition, subtraction, multiplication, and division operations will result in values whose signs are determined by the usual rules of algebra. These rules apply when neither operand is unsigned. If one operand is a floating point type and the other is a character or an integer, the character integer will be converted to the floating point type of the other operand and the result will be expressed. So an operation between an integer and a double will result in double. If both operands are floating point types with different precisions, the lower precision operand will be converted to the precision of the other operand, and the result will be expressed in this higher precision. If neither operand is a floating point type or a long int, then both operands will be converted to int and the result will be int. If neither operand is a floating point type, but one is a long int, the other will be converted to long int and the result will be long int. Unary operator. C includes a class of operators that act upon a single operand to produce a new value. Such operators are known as unary operators. Unary operators usually precede their single operands, though some unary operators are written after their operands. The most common unary operator is unary minus, where a minus sign precedes a numerical constant, a variable or an expression. An example is shown here. Of all the arithmetic operators, the unary minus has the highest precedence level.
The most well-known and most talked about unary operators in C are the pre- and post-increment and decrement operators. Before C appeared, this sort of operation did not exist in any higher level language. C was written by and for assembly language programmers of the PDP-11 computer, which has increment and decrement instructions in the hardware. When they developed a higher level language, they didn't want to do without those instructions, so they put them in. All they do is either add one or subtract one from a variable. It works with a long, short, or any type of integer, and that's the way it's normally used, but it works just as well with a float or a double. It is exactly the same as adding or subtracting one, no matter what type of variable is involved. You are, of course, familiar with the ampersand and the asterisk unary operators. The ampersand is a unary operator that returns the L value, the address. The asterisk is a unary operator that uses the L value, the address, to extract an R value, the number stored at the address. But look at this. The square brackets are a unary operation that work exactly the same as the asterisk. The square brackets work for any pointer just like an asterisk. When you run the program, it looks like this. Both the asterisk and the brackets with a 0 offset return the value addressed by the pointer. The unary plus sign is implied. You can include it or not. It does not modify the value in any way. On the other hand, the unary minus reverses the sign of a number. If it's positive, it becomes negative. If it's negative, it becomes positive. A similar unary operator is the tilde character. It results in the ones complement of the integer value. All 1 bits are converted to 0, and all 0 bits are converted to 1. The exclamation point is the logical complement operator. If the value is 0, the result is the number 1. If the value is anything other than 0, the result is 0. One more. This one looks like a function, but the size of operator is actually a unary operator, and it's part of the language. It results in the size in bytes of its operand, and it's not valid to use it on any incomplete type or on a bit field. It derives the size from the type of the operand. The size calculations are made by the compiler, and the value is then inserted into the code as an integer constant.
Now we shall discuss about logical operator. A logical operator is used to compare or evaluate logical and relational expressions. There are 3 logical operators available in the C language. For example, for expression C equals 5, logical and D greater than 5 to be true. Both C equals 5 and D greater than 5 should be true, but D greater than 5 is false in the given example. So the expression is false. For expression C equals 5, logical, or D greater than 5 to be true, either the expression should be true. Since C equals 5 is true, so the expression is true. Since expression C equals 5 is true, logical not C equals 5 is false. We shall discuss about bitwise operator. One of the great strengths of C is the way that it allows systems programmers to do what had, before the advent of C, always been regarded as the province of the assembly code programmer. That sort of code was by definition highly non-portable. As C demonstrates, there is not any magic about that sort of thing, and into the bargain it turns out to be surprisingly portable. Bitwise AND operator. The output of logical AND is 1 if both the corresponding bits of operand is 1. If either bit is 0 or both bits are 0, the output will be 0. It is a binary operator and indicated in C programming by ampers and symbol. Bitwise OR operator. The output of bitwise OR is 1 if either of the bit is 1 or both the bits are 1. In C programming, bitwise OR operator is denoted by pipe. Bitwise XOR, exclusive OR operator. The output of bitwise XOR operator is 1 if the corresponding bits of 2 operators are opposite. It is denoted by caret. Shift operator. There are 2 shift operators in C programming. right shift operator and left shift operator. Right shift operator. Right shift operator moves the all bits towards the right by certain number of bits, which can be specified. Left shift operator. Left shift operator moves the all bits towards the left by certain number of bits, which can be specified. Now let's talk about assignment operator. In C programs, values for the variables are assigned using assignment operators. For example, if the value 10 is to be assigned for the variable sum, it can be assigned as sum equals 10. Remember that there is a remarkable difference between the equality operator equals equals and the assignment operator equals. The equality operator is used to compare the two operands for equality, same value, whereas the assignment operator is used for the purpose of assignment. Multiple assignments. One can use the assignment for multiple assignments that are A equals B equals C equals 10. At the end of this expression, all variables A, B, and C will have the value 10. Here, the order of evaluation is from right to left. First 10 is assigned to C, hence the value of C now becomes 10. After that, the value of C is assigned to B, hence the value of B becomes 10. Finally, the value of B is assigned to A, hence the value of A becomes 10. Arithmetic assignment operators. Arithmetic assignment operators are a combination of arithmetic and the assignment operator. With this operator, the arithmetic operation happens first, and then the result of the operation is assigned.
As you can see, using code blocks, I've saved a file. I've given it the name assignment_operators.c. On line 1 in this file, I have a header file, the stdio.h header file. On line 2, I've declared the main function. On lines 3 and 4, I have my curly braces. So between the braces, I'm going to type in the code. And the program that I'm going to make in this tutorial is going to be very simple, and it's not going to do anything fancy because I just want to illustrate the operators to you. So all we're going to do is declare two variables, and the first one I'm going to call A. Both the variables are going to be integers. So to declare the variable, I'll have to type in int, the keyword that you use to declare integers, and then the name of the variable, which as I said, I'm going to call my variables A and B. And then I'll give A the value 15 using the equal to assignment operator, right? On next line, I'm going to declare another variable. I'm going to call this one B. And if I want to copy the value of A to B, all I have to do is type in B equals A and then put a semicolon to terminate the statement. And the value of A will be copied to B. And if you want to check, you can do that. Use printf, and let's display a message first. Value of B is %d format specifier because B is an integer, and then type in the name of the variable after the comma symbol. Save the file, and if I click on build and run, you would see that in the output window I get the message value B.
Now we shall discuss about conditional operator. A conditional operator checks for an expression, which returns either a true or a false value. If the condition evaluated is true, it returns the value of the true part of the operator. Otherwise, it returns the value of the false part of the operator. Conditional operators are used in decision-making in C programming. Example, executes different statements according to test condition, whether it is either true or false. Syntax of conditional operators is as shown here. If the test condition is true, expression 1 is returned, and if false, expression 2 is returned. Let's now talk about preprocessor commands. The C preprocessor is not part of the compiler, but is a separate step in the compilation process. In simplistic terms, a C preprocessor is just a text substitution tool, and they instruct compiler to do required preprocessing before actual compilation. Use of the preprocessor is advantageous since it makes programs easier to develop, easier to read, easier to modify, C code more transportable between different machine architectures. Hash include. This command slurps in a file and inserts it at the current location. The main difference between the syntax of the two items is that if file name is enclosed in angled brackets, then the compiler searches for it somehow. If it is enclosed in quotes, then the compiler does not search very hard for the file. While the behavior of these two searches is up to the compiler, usually the angled bracket means to search through the standard library directories, while the quotes indicate a search in the current directory. Hash define. The hash define command is used to make substitutions throughout the file in which it is located. In other words, hash define causes the compiler to go through the file, replacing every occurrence of macro name with replacement string. The replacement string stops at the end of the line. Hash if def. These commands give simple logic control to the compiler. As a file is being compiled, one can use these commands to cause certain lines of code to be included or not included. Hash if expression. If the value of expression is true, then the code that immediately follows the command will be compiled. Hash if def macro. If the macro has been defined by a hash defined statement, then the code immediately following the command will be compiled. Hash if and def macro. If the macro has not been defined by a hash defined statement, then the code immediately following the command will be compiled. Macro instruction. A macro instruction in computer programming is a single instruction that, when a program is compiled, is replaced by a predefined block of code. The term was originally applied to instructions used in assembly language programming, in which long, repetitive code was sometimes needed for very simple operations. Let us know about input-output. All C programming input and output is done with streams, no matter where input is coming from or where output is going to. This is the standard way of handling all input and output and has definite advantages for the programmer. Data can come from some location external to the program. Data moved from an external location into RAM, where the program can access it, is called input. The keyboard and disk files are the most common sources of program input. Data can also be sent to a location external to the program. This is called output. The most common destinations for output are the screen, a printer, and disk files. GetChar method. The function getChar obtains the next character from the string stdin. It provides buffered character input with echo. The getChar function is called and waits to receive a character from stdin. Because getChar function is a buffered input function, no characters are received until one press enter. However, each key one press is echoed immediately on the screen. Using the getch function. The getch function gets the characters without echoing them to the screen. One knows the characters are being gotten because the original listing uses putchar function to display them. Remember that getch function is not an ANSI standard command. This means that the compiler might or might not support it. Getch function is supported by Semantic and Borland. Microsoft supports _getch function. The getchy function. Getchy function is exactly like getch function, except that it echoes each character to std out. Modify the program in the getch function portion to use getchy function instead of getch function. And when the program runs, each key one presses is displayed on screen twice once as echoed by getchy function, and once as echoed by putchar function. Getchy function is not an ANSI standard command, but many C compilers support it. Putchar function. The C library's character output functions sends a single character to a stream. The function putchar function sends its output to std out. The functions fputc function and putc function send their output to a stream specified in the argument list. The prototype for putchar function, which is located in stdio.h, is shown here. Using the putc and fputc functions. These two functions perform the same action, sending a single character to a specified stream. Putc function is a macro implementation of fputc function. Its prototype is shown here. Using puts and fputs function for string output. The programs display strings on screen more often than they display single characters. The library function puts displays strings. Scanf function. The input functions covered up to this point have simply taken one or more characters from an input stream and put them somewhere in memory. No interpretation or formatting of the input has been done, and one still has no way to input numeric variables. For example, how would you input the value 12.86 from the keyboard and assign it to a type float variable? Enter the scanf and fscanf functions. These two functions are identical, except that scanf function always uses stdin, whereas the user can specify the input stream in fscanf function. The scanf function format string can contain spaces and tabs, which are ignored, characters which are matched against non-white space characters in the input, one or more conversion specifications, which consist of the percentage character followed by special characters. Printf function. To display numbers, one must use the C library's formatted output functions, printf and fprintf. These functions can also display strings and characters. The functions printf and fprintf are identical, except that printf always sends output to std out, whereas fprintf specifies the output stream. fprintf is generally used for output to disk files. Take a look at these simple examples. The statement printf hello world displays the message hello world on screen. This is an example of using printf with only one argument, the format string. In this case, the format string contains only a literal string to be displayed on screen. The statement printf %di displays the value of the integer variable I on screen. The format string contains only the format specifier %d, which tells printf to display a single decimal integer. The second argument is the name of the variable whose value is to be displayed. Getch function. The line input functions read a line from an input stream. They read all characters up to the next new line character /n. The standard library has two line input functions, gets and fgets. Gets is a straightforward function, reading a line from stdin and storing it in a string. The return value is a pointer to the string. If gets function encounters an error or reads end of file before any characters are input, a null pointer is returned. The function prototype is shown here. The fgets function. The fgets library function is similar to gets in that it reads a line of text from an input stream. It is more flexible because it lets the programmer specify the specific input stream to use and the maximum number of characters to be input. The fgets function is often used to input text from disk files. To use it for input from stdin, one specifies stdin as the input stream. The prototype of fgets is shown. Puts function. It is used to display a string on a standard output device. The puts function automatically inserts a new line character at the end of each string it displays, so each subsequent string displayed with puts is on its own line. Puts returns non-negative on success. Functions. The C standard library has a variety of functions that deal with stream input and output. Most of these functions come in two varieties, one that always uses one of the standard streams and one that requires the programmer to specify the stream. The gets function is used to input a line of text from the keyboard. Because gets returns a pointer to the string, it can't be used as the argument to puts, which displays the string on screen. When run, this program inputs a line of text from the user and then immediately displays the string on screen. Now in the end, let us summarize what we have learned in this lecture. An operator indicates an operation to be performed on data that yields a new value. Expressions in C are basically operators acting on operands. Statements like A equals B plus 3 plus Z and 300 greater than 8 times K are all expressions. A statement causes the computer to carry out some definite action. C includes a class of operators that act upon a single operand to produce a new value. Such operators are known as unary operators. One of the great strengths of C is the way that it allows systems programmers to do what had, before the advent of C, always been regarded as the province of the assembly code programmer.